To create a new package footprint for a component in orcad or allegro, you start off by saying File, New, and then it asks you for a drawing name. So we're doing a BMP 180. That is the component we're creating a footprint for. And then we must say that it is a new package symbol. You say OK. The next thing we want to do is change the drawing option. So you go to Setup, Change Drawing Origin, and we just click the mouse over there, and that will make it the new drawing origin. And if you zoom in, you can see there, when you've got your mouse over there at the bottom of the screen, it shows you that you're at the 0 point. The reason for doing this is if your 0 point was in the bottom left and you've got negative offsets when you create your package, then you are outside of the drawing area. So if you locate it somewhere else so that you've got space all around the drawing origin, then you can have the drawing origin, the 0 point, at the center of your part. At this point, there's a short segue into creating the actual pad stack for the pins that we're going to use for this part. As mentioned in the preamble, because this part is an LGA, which has got the pads underneath the components, similar to what you would find in a QFN, it's extremely stressful trying to hand solder LGA or QFN parts onto a prototype board. So what we do is we take the pad size on the data sheet and increase it so that the pad actually comes out from underneath the component, which allows you to supply your soldering iron to the pad to apply heat so that you can have a better chance of hand soldering these for your prototype boards. The pad dimension for this component is 0.5 millimeter by 0.6 millimeter. We've converted these up to mils because here we are using mils. That's what we use throughout our design. You could change it to millimeters or inches, but we'll keep it at mils. Because it's a surface mount device, we go to layers here and we put it in single layer mode. On your beginning layer, we want to put a regular pad. So we would say it is a rectangle, and we put the width and height of the pad into this block and that block. In order to view what you're creating, you just click here to say you want to look at the top view. So on the beginning layer, our rectangle is going to have a width of 23.7 mils and a height of 39.4. And there you can see that's what you'd get on your top layer. For the solder mask layer and on the top, and the paste mask on the top, normally one would choose a size slightly bigger than that one for the solder mask, and for the paste mask a size slightly smaller. What we found is that the people that make the silkscreen and solder paste stencils want the correct size, and then they decide, depending on their machinery, whether to over or undersize it. So we just stick with these dimensions. On the solder mask top, once again, we'll say we've got a width of 23.7 and the height of 39.4. We then go to the next layer, which we don't have because it's just a surface mount component. There's a paste mask for your solder paste stencil. So as mentioned before, we put in 23.7, 39.4, and we're basically done with this. So you could look at a cross section, which is pretty meaningless. That's the cross section. You want to look at the top. So at this stage now we say File, Save As, and I'll just call it BMP Pad, and we just save it. It's now saved it, but you must be sure that you know where it's been saved. In this instance, it's in your library footprints directory. Okay, back to where we started. So you close the pad designer down, and we're back here on our blank page. The next thing that we do is layout pins. So you click on layout pins, and this is why we had to create the correct pad stack, because the first thing you're required to do is to select the pad stack for the pin. So you'll go to your pad stack directory and we'll go and look for BMP pad. There's the BMP pad that we created. We say OK, and that pad now is attached to your cursor. You may have to zoom in because this is a very small pad, so you can see the pads attached to the cursor. Now the first thing you'll notice is that as I move around, we're snapping to the grid, which is going to make it extremely difficult to place this pad where we want. So what we'll do is we enter the XY coordinates of where we'd like the pad to be. So we refer back to our drawing that we did, and for pin number 1, you can see here we've got BMP pad. It's a connection pad. If you clicked over here as a mechanical pad, that would be, for example, for a mounting hole, but we want to connect a track to this pad. There's your spacing between X and Y. So without further ado, let's get on with entering the XY coordinates for this pin 1. We also would like this to be in this orientation. If you have to rotate it, you go up here to rotate the pad, but this is the correct orientation. So we go to the bottom of the screen and we say X space minus 59.06 space Y space minus 57.08 and enter, and there your first pad has been placed. It's now automatically gone and it's waiting for pin number 2. That's the text block, and that's the offset of where the text is. So you'll see that the text is 50 mils to the left of the pad. That's the text number 1. Ideally what we would want is the text to be below the pad, but because this isn't on a particular layer, I'm not too bothered about that now. So pin number 2, we'll just go back and we'd say X space 0, Y space minus 57.08 and enter. And there's your second pad. Pad number 3 is X space 59.06. That's not negative because in the X direction it's on the right hand side of the origin. Space Y space minus 57.08 and enter. You can see here that's how I wanted to have the origin of the component at the origin of the page. So we've got it nicely centered around here. It just makes it easier right at the end of the process where you've got a automatic pick and place machine, and it takes this as the center of the component. So if you rotate it, you don't get components being placed at weird angles on your PC board. I'm just going to place the other 4 pins quickly. Okay, the last pin on this device we actually want to be rotated so it comes out from underneath the component. So we just go up here and we say we want to rotate it by 90 degrees, and as you can see it's been rotated, and now we can put the X and Y positions for this part. At this point we placed all the pins, pin 1, 2, 3, 4, 5, 6, 7. So you right click on your mouse and you say done. So we're out of that mode and the pins have been correctly placed. If you wanted to check, you could just say display, measure, and you could go and measure from the center of that pin to the center of that pin, and the measurement box tells you the air gap between the parts and the actual distance, 59.06. So just as a sanity check, it's advisable to basically measure the placement of all these pins. The more time spent up front making your footprint saves you hours and hours when you get right downstream. You pay a lot of money and get your prototype board and the component doesn't fit correctly. After you've done your various measurements, you just do right mouse button and you say done. Let's just go and zoom in so this is in the center of the screen. What we want to do now is you want to add a rectangle on the assembly top layer. So we say add rectangle, and we want to add it on the package geometry assembly top layer. See, it's a solid line. We want to draw a rectangle, but because of the small dimensions, we're going to once again enter the bottom left corner as x minus 75 space y minus 71, and the top right hand corner as x 75 y 71, and there it is. And we just push the right mouse button and say done. You'll notice here what I was talking about. Because we've extended these pads, there's a small portion of the pad peeping out from underneath the component. If we didn't do this, these pads would be completely under the component, and hand soldering them is just about impossible. This line that we've just created, this rectangle, normally only appears on the assembly drawing, so it doesn't really matter that it goes through the pad. We are now, however, going to do the silkscreen top layer, and it's important not to have the silkscreen printed over the top of the pads. So what we'll do here is, once again, we'll add. You can either do a line or a rectangle. It's advisable to do a line because then you can set the line width. So what we do here is say add a line, and here you can see you can put the line width. Now it's very important that your PC board fabricator can handle the line width. If you put a line width of 4 mils and they can't go lower than 8 mils, you're going to get a board back with no silkscreen on it. So once again, start at the end of the process and work back. Find out from your fabricator what is the minimum line width that they're able to silkscreen. So in our case it would be 8 mils, and we want to lock the line to be orthogonal at 90 degrees. Now we've got to select the right layers, so we want it to be on the package geometry silkscreen top layer. So just roughly, if I want to put the line down here, you can see it's snapped to this grid point, which we don't want. So you right click and you say oops, and it's gone back. Now in order to get over that problem, you've got to change the grid size. We do this by going to setup, grids, and for the grid spacing, what we'll do is, instead of 100 mils, I'll just make it 5 mils, 5, and the spacing on the top layer 5, 5. The bottom isn't really relevant, but for completeness we'll make it 5, and then we say okay. Now we've got a tighter grid spacing, so if we go back now to drawing our line and I put the start point over there, you can see I'm quite easily able to draw the line. Let's just go around here, go around here, go around here, and then back to the beginning, and then right click and say done. That has now placed our silkscreen on the top, and we might want to put a designator to show where pin 1 is. For this we would say add a circle on the package geometry silkscreen top. We still keep the same line width so it is visible when we actually take it to the fabricator. Here's our pin 1, so we'll draw a circle over there, right mouse button, and done. We may want to do the same thing on the assembly top. So what we'll do is just say we want to add a circle, and in this instance we can have a 0 line width, and it's on the package geometry assembly top layer, and we'll just put a circle here for the pin 1. Right click and done. The next step is to add the reference designators to the footprint that you're making. So you would say layout, labels, ref des, and you will go and see that your ref des here on the assembly top, you've got a text block, and we normally use 3. This is your text block size. If you need clarification of what this text block 3 means, you can go to setup, design parameters, and you click here on text, and you can see the parameter block 3 means that this is 50 mils in height, if you click on this icon there, you'll see it pops up a window and it shows you the width and the height and the line spacing. These are the characteristics of text block 3. So you can change these to suit, but we normally use a text block 3 in our designs, and once you've done that you can either add, reset, or just say OK. So now that we've got all of that done, we want to put the reference designator on the assembly top. So you would click in the middle of this IC, and for ICs we use the symbol U, and you say U star and enter. It then changes it to a dotted line. You push right mouse button, done, and there's your reference designator on the assembly top. Now clearly on the silk screen you'd like to see printed on the silk screen U27 or whatever the IC number is. So what you'd do then is you'd go back to layout, labels, reference designator, but at this stage you'll say you want that to be on the silk screen top. Now you don't want that underneath the IC, so you'll find a place to locate it. We've got the same text that we're using with the marker size. It's left justified, so I'm going to say I want it center justified, and I'll go over here, give it a bit of space, and say we want this to be U star, enter. Right click, done, and you've basically now completed putting your reference designators on. The next step is to place some constraints so that a package won't be placed too close to another package. This has downstream implications with design for assembly. So what you can do right in the beginning when you create the footprint, you can create what's called a place bound dimensions, which means there's a boundary around this component that you can't place anything closer than that. To implement this, we say shape, rectangle. We want to put this rectangle on the package geometry layer, on the place bound top layer. So all we do now is it's asking us to draw a rectangle. So I would typically start there, and I'd say about there. And you can see this puts the place bound area, so no other components will be able to be placed closer than that to this component. Right click and you're done. Once this is done, you can also give the package a height dimension, which is very useful further downstream where you're trying to put your product into a housing, and you obviously don't want the housing to interfere with the package height. This is very relevant for things like capacitors, which have got quite a high vertical dimension. So here you just go and say setup areas, package height, and here it says your package height. You go and select the area, so I'll just left click on there. We say what the minimum height is for this, so let's just for example say 200 mils, or no, we want to close, it's on the PC board, so we'd say 2 mils, and the maximum height is 210 mils. Once you've done that, you just right click and you say done. So now you've got a vertical height of this package on the place bound area. The very last thing to do now is to have a root keep out area. This may be a transformer, or just an area where you don't want the auto router to start running tracks underneath this particular component. So you'd once again say add a rectangular shape, and you want that on the root keep out area layer. You can see it's the subclass is on all layers, or you can have it for example just on the top layer. So it's a surface mount component. We don't care if they route tracks in this instance underneath the component on the inner or bottom layers. So we just want a root keep out on the top layer, and I would suggest that perhaps we draw a rectangle here, and that means no tracks will be able to be routed in this particular area. Right mount button, done, and now we're complete. So what you'll do is just say file, save, and it saves your complete footprint and the design, so you're ready to use this now in any particular design that you do which uses this part, the BMP 180.